threats of global catastrophe as normal news. Climate change, pandemics, nuclear war, asteroid impacts. End of the world talk is common discourse. It's no longer limited to fringe fanatics and street corner preachers. I've been like most, recognizing the real issues, skeptical of the inflamed rhetoric. But in private moments, I have thought it odd that global catastrophe is now threatened after only a few thousand years of human history. And I blink in an almost 14 billion-year-old universe. Why so soon, I've wondered. That's when I heard about an odd scientific argument that claims to justify end-of-the-world worries. It's called the Doomsday Argument, and I cannot ignore it. What is the Doomsday Argument? I'm Robert Lawrence Kuhn, and Closer to Truth is my journey to find out. The Doomsday Argument seems to rely on pure statistics, assigning grim probabilities to human extinction, but it makes no reference to real-world threats. The argument goes something like this. Because we should be average human beings, the extinction of human beings could be soon. Silly, I'd think. But leading scientists and philosophers are discussing the argument. I'm taken aback, and I decide to pursue it. I begin with one of the champions of the Doomsday Argument, author of The End of the World, The Science and Ethics of Human Extinction, philosopher John Leslie. John, you've written about something called the Doomsday Argument, which is a new way of thinking about humanity and our likely survival.
This Doomsday Argument was dreamed up by Brandon Carter. It's a very controversial argument. Let me creep up on it, therefore. There are, in the universe, more suns than there are grains of sand in all the world's beaches. What would you think of somebody who said life is going to exist all over the universe, scattered all among these suns, but the existence of extraterrestrials, why we haven't noticed it, should be explained as follows. We are the very first intelligent species to evolve. Later there will be trillions and trillions and trillions of intelligent species colonizing planets, going on to colonize the galaxies, but we are the very first. This would seem to me a fantastic hypothesis. It would put us in such an extraordinary position. I would prefer the hypothesis that the reason we don't see extraterrestrials is that they've almost always destroyed themselves as soon as they've developed advanced technologies. Now, let's look at a little variant on that same way of thinking. Suppose that we manage to get off the Earth and colonize our galaxy. The galaxy itself has an enormously large number of stars. If we spread through the galaxy, then you and I will have died long before the spreading takes place. But if the human race spreads through the galaxy, you and I will have been enormously early humans in a statistically extraordinary position. Can we believe in this? Isn't this like believing that we're the very first intelligent species to evolve in the entire universe, which seems such a stupid hypothesis? If the human race managed to destroy itself very quickly, then something like 1 in 10 humans would have been alive at the same time as you and me because of the recent population explosion. That makes us pretty average, 1 in 10 people. If we manage to colonize the galaxy, that makes us in the 1 in a billion class, something like that. An extraordinary position. This gives a new reason for pessimism.
So let's put that on the table. The statistical likelihood that we are not this extraordinarily small early sample of humanity, which puts a spotlight on our current situation and saying, are we now vulnerable to species-destroying events, either our own cause or caused upon us, that perhaps we are not aware of?
Yeah, I think that what this Doomsday Argument does is to magnify any risks which we see. If we were tending to take these risks not very seriously, having looked at this argument, we should take them much more seriously than before. And we also ought to take seriously that there are some risks which we simply haven't thought of. We ought to keep our eyes open very carefully.
The Doomsday Argument is based on a simple premise. In any situation, unless there's evidence to the contrary, we should always consider ourselves average. If the human race would last millions of years and spawn trillions of human beings, perhaps throughout the galaxy, then we would be living in the very earliest stages of human history. But statistically, that would seem unexpected. Why would we be not average? One reason, of course, is that somebody has to be not average. But the more likely reason, goes the Doomsday Argument, is that we are average, which would mean that we are not living so early in human history, which would mean that human history will not be lasting very much longer. My reaction, as with almost everyone who hears the argument, is that there must be something wrong with it. How could such potent conclusions be deduced from such flimsy premises? I saw that the Doomsday Argument was developed independently in different ways. Brandon Carter was the first, enriched by John Leslie. A second was a professor of astrophysical sciences at Princeton, J. Richard Gott. How did Richard frame the Doomsday Argument?
Well, this started with a trip I made to the Berlin Wall in 1969. People wondered how long it would last. Was it a permanent fixture of modern Europe, or would it disappear in the near future? So I was there with a friend of mine, and I made the following prediction. I said, look, I'll use the Copernican principle. It's the idea we use in astronomy that your location isn't likely to be special. As we've discovered, we do not live in a special place at the center of the universe. We're going around an ordinary star in an ordinary galaxy in an ordinary supercluster. The Copernican principle works because out of all the places for you to be, there are many non-special places and only a few special places. So you're likely to be at one of the many non-special places. So I made the following argument. I said, I'm here looking at the Berlin Wall. I'm somewhere between the beginning and the end of the Berlin Wall. And if my location isn't special, there's a 50% chance I'm in the middle 2 quarters. And if I'm at the beginning of that middle 2 quarters, then there's 1 quarter that's passed already and 3 quarters in the future. So the future is 3 times as long as the past. On the other hand, if I'm at the end of that middle 2 quarters, I got 3 quarters of the past and 1 quarter in the future. So the future is 1/3 as long as the past. So there's a 50% chance that you're within the middle 2 quarters, you're between those 2 limits, and that the future of the wall will be between 1/3 and 3 times as long as it's past. So the wall was 8 years old at the time. So I said to my friend, look, there's a 50% chance it'll last at least 2 2/3 years, that's 8 divided by 3, but less than 24 years, which is 8 times 3. So 20 years later, in 1989, I called him up. I said, Chuck, turn on the TV. Tom Brokaw is at the wall. They're bringing it down today. You remember this prediction that I made. So it came 20 years later, within the 2 limits. So when this turned out, I thought, well, I should write this up. So when scientists write up predictions, though, we like to be 95% correct, not just 50% correct. So how does this argument change? Well, it says that if you're looking somewhere between the beginning and the end, there's a 95% chance you're in the middle 95%. In other words, not in the first 2.5%, not in the last 2.5%, but somewhere in this big 95% region. So 2.5% is 1/40th. 2.5% is 1/40th of the total. So if you're over here at this limit, then this 1/40th has passed and 39/40ths are still in the future. So the future is 39 times as long as the past. On the other hand, if you're way over here still within the middle 95%. There's 1/40th in the future and 39/40ths in the past. So in that case, the future is 1/39th as long as the past. So the 95% confidence prediction is the future of the thing you're looking at will be between 1/39th and 39 times as long as you've been observing it in the past. Okay. So I thought I'd apply this to something important, the future of the human race. We've been around for 200,000 years. That's back to mitochondrial Eve. That's our species, Homo sapiens. Well, 1/39th of that is 5,100 years. So this says we'll last 95% sure, we'll last at least 5,100 years, but less than 39 times that, or 7.8 million years. So we'll last somewhere between another 5,100 years, but less than 7.8 million years. Now, that's very interesting because it's calculated solely on our past lifetime as an intelligent species. But interestingly, that gives us a predicted longevity of between 205,000 years at the short end and 8 million years at the long end. That's quite similar to other mammal species that are here on Earth. Their mean longevity is 2 million years. And Homo erectus, our previous species, lasted about 1.8 million years, and the Neanderthals, they lasted about 300,000 years. So these numbers are quite similar, and yet the calculation is only based on our past longevity. So it should give us pause that our past longevity suggests that we may be in as much danger as these other species.
Perhaps we should take some steps to propagate the human race away from Earth.
Well, yes. One of the things that you notice is that we're having this conversation on the Earth. This is not good because if we don't colonize off the Earth, you and I are entirely typical. Everyone born would be born on the Earth. If we colonize the whole galaxy, you see, in the future, you and I would be very lucky to live on the very first planet when there were like 1 billion planets that we colonized. So it warns us that if our observations are typical, there's a significant chance that we would get stranded on the Earth. And it's better to have more locations. So it's a great life insurance policy for us to plant a colony on Mars because that would give us 2 chances. And so right now, I mean, there's lots of threats. So we're kind of like on the Titanic and we've got no lifeboats. So we should have some lifeboats. It's smart for us to spread out, and we don't have all that much time because the space program itself.
I follow the argument and see the logic, but still I feel I'm being, well, tricked, with good spirits, of course, by a statistical magician. When arguments seem tenuous, check their assumptions. The Doomsday Argument is based on several deep assumptions. One is called the observation selection effect. The position of the observer affects the results of the observation. In the Doomsday Argument, human beings living now are the ones assessing the likely longevity of all human beings at all times. I go to Oxford, England, to visit a leading expert on these assumptions, the director of the Future of Humanity Institute, Nick Bostrom.
The Doomsday Argument is strange because it seems to rely on very weak empirical premises. So one way you could become convinced that the world is dangerous and might end soon is if you study particular risks and you think about nuclear weapons and designer pathogens and you study the details of that and you think this looks really scary. But the Doomsday Argument is much more general, and it says that whatever the prior probability of human extinction that you come up with after you have studied all these individual disaster scenarios, you should revise that upward after reflecting on your position in the human species, conditional on 2 different hypotheses. So let me explain this by means of an analogy. Suppose you have an urn with balls in it, and the balls in this urn are numbered from 1, 2, 3 upwards to the total number of balls. And you're not sure whether the urn contains 10 balls or 1,000,000 balls. It's a big urn, and it could be almost empty, or it could be full with balls. So you got to guess which one it is, but you get one clue. You get to pick one ball from this urn and pick it up and look at it. And so you do that, and you find that it's number 7. Now, in this urn example, picking ball number 7 gives you very strong evidence that the ball is the 10-ball urn rather than the 1,000,000-ball urn, because it's much more likely you would get number 7 if there are only 10 balls than if there are 1,000,000. And so that's uncontroversial, but here is the analogy. Think of the 2 different urns as 2 different hypotheses about what will happen to the human species. So one hypothesis is that we will go extinct soon, maybe in a few decades, and there will have been a total of, I don't know, 100 billion humans will ever have lived from the rise of our species to its end. And another hypothesis is that we'll survive, colonize the galaxy, and maybe we'll live for millions and millions of years, and there might have been a total of 100 trillion humans in total. Just pick 2 numbers. And suppose that after having studied the specific risk, you think it's 50-50. And then, corresponding to picking this ball, number 7, you think of yourself as a random sample from all humans that will ever have lived. And the number is your birth rank, your place in the sequence of all humans. So your number would be round about 70 billion. So that's how many people have come before you. And so the idea is that the probability that you should find yourself with birth rank 70 billion is much greater if there will only be 100 billion humans in total than if there will be 100 trillion, for the same reason as in the urn case. So the conclusion of the Doomsday Argument is that whatever the prior probability of doom soon versus doom late, after reflecting on this, you should sort of up your probability in doom soon to take into account of your low birth rank.
So whatever probabilities may cause human extinction based on nuclear weapons or asteroids or biological warfare, whatever those probabilities are, you're saying that the Doomsday Argument increases those by some factor.
That's right, which depends on the exact numbers involved. So that's the idea behind the Doomsday Argument. And intuitively, it seems it must be wrong.
Yeah.
Because you seem to get a lot of information from no sort of evidence, as it were. And there have been a lot of attempts to explain why the Doomsday Argument fails. And when you look more carefully at these attempts to explain why it's wrong, they tend to fail. Now, my view is that ultimately the Doomsday Argument is inconclusive, but not for any simple, trivial reason, but for deep methodological reasons that have to do with observation selection theory and the way you should reason about these things. But the idea in the Doomsday Argument that does the work is that in some sense you should think of yourself as if you were a randomly selected observer or a random human. And I think there is an element of truth to that. It's not as silly idea as it might appear. But these arguments that support that assumption, if you look carefully, don't support strictly the assumption that you should think of yourself as a random human from all humans that will ever have lived. It supports a weaker assumption that you should think of yourself as a random human from some suitable set of humans, not necessarily the whole human species. And if you pick a more narrow reference class, you can avoid the Doomsday Argument.
It sounds, though, that based upon people's concern already about the possibility of human extinction, the Doomsday Argument at least puts an additional caution into how humanity should behave.
I would put it slightly differently. If the Doomsday Argument were sound, then it would put a huge extra caution. If I'm correct and believing it's not sound, then it might not actually carry any weight at all. Now, if we are uncertain about whether I'm right or not, then we might give it a little credence, and it might affect our, probability estimate slightly.
Well, based on what it's talking about, it's not talking about whether we go on vacation next month. It's talking about human extinction. We probably should have a little bit extra caution.
My view is that we should have exactly the degree of caution that the evidence warrants. And at least if we were rational, there would be no need to sort of hype up the probability of a disaster, because even a tiny probability of humanity going extinct ought to be enough to motivate us to take whatever action is needed to reduce that within reasonable limits.
I agree with Nick on both accounts. The Doomsday Argument is likely not sound, and we must study the survival of our species. One of the most eloquent voices warning humanity about existential threats is the UK Astronomer Royal, the author of Our Final Hour, Martin Rees.
We sometimes think that cosmologists, because they think about billions of years, are somehow serene and relaxed about short-term problems. But I worry as much as anyone about what's going to happen next year, next week, or tomorrow. And I think actually that being a cosmologist gives one a special perspective on these issues, because although most educated people are aware of the billions of years of the past, leading from simple life on Earth to humanity, they tend to think that we humans are in some sense the culmination. Whereas one thing which we learn from astronomy and cosmology is that the time lying ahead is at least as long as the time that's elapsed up till now. The universe may go on forever, but even our Earth and Sun is less than halfway through its life. Even in the cosmic perspective of billions of years, this century is very special. And let me explain that by a sort of cosmic vignette. Suppose you were an alien who'd been watching the Earth for its entire 4.5 billion year history. Over most of that time, change would have been very slow. The continents would have gradually shifted, species would have formed, evolved and become extinct, ice ages came and went. But then things started to change more rapidly. About 10,000 years ago, vegetation started to change because of human agriculture. But then change speeded up immensely. Within just 50 or 100 years, 1/100th of 1/1,000,000th of the lifetime of the Earth. The carbon dioxide in the Earth's atmosphere started to rise enormously fast. The Earth became a source of radio signals, the integrated effect of all TVs, radars, mobile phones and the rest. And something else remarkable happened. For the very first time, projectiles lifted from the Earth's surface, went into orbit around it, some even went to the moon and the planets. If the aliens had been watching this, they'd have seen something remarkable happening in this tiny stretch of time. So what's going to happen in the next century? If the aliens keep watching, what will they see? Will this sudden spasm, less than halfway through the Earth's life, be followed by silence? Or will it lead to some new stable situation? And will some of these projectiles leaving the Earth eventually spawn new oases of life elsewhere? So that's the challenge for us. So these are the options which we can't predict. And these aliens, if they understood astronomy, could have predicted that the Earth was going to die in a few billion years when the sun flared up and engulfed the inner planets and vaporized life on Earth. Because they have predicted this sudden spasm happening less than halfway through its life with runaway speed. And I think if you look at things that way, you realize that what we do here on Earth has an impact that will resonate not just through the life of our children or grandchildren, but into the far future, here on Earth and perhaps far beyond, because this is a crucial century, even in the perspective of billions of years that cosmologists talk about. I think if people are aware that if we were to destroy our civilization, it would foreclose potentialities of even a post-human era far beyond the Earth as well as on it, then that gives an extra motive for concern. We are the stewards of this planet at a special period.
The Doomsday Argument warns that we have underestimated the risk of human extinction. While the argument's simple statistics seem to extract too much conclusion from too little evidence, something is going on here. The Doomsday Argument combines 4 big ideas. 1, the Copernican principle that human beings do not occupy a special location in the universe. 2, our surprising temporal position in humankind's short or long history. 3, the importance of the observer in observations. 4, the survival of our species. John Leslie advises taking existential risks seriously. Nick Bostrom advocates studying existential risk. Martin Rees puts existential threats into cosmological perspective, and he stresses the critical nature of our current century. I take another view. I still marvel at the vast difference between the long ages of the universe and the short span of human history. After billions of years in preparation, could humanity's future be decided when we and our children are alive? Could there be something special about our generations, so we'd not be living in average times? Could violating the Copernican principle bring us closer to truth?
For complete interviews and for further information, please visit closertotruth.com.